Hello, everybody. My name is Kevin Dobis, and I'm going to introduce the WaveJudge 5000 to you today. This is the latest product in the Keysight portfolio. We became a part of the Keysight family just recently in the past few months. So the objective for today is that at the end of the session, you should have a very good idea of the kind of a high-level overview of what the WaveJudge 5000 does, where it fits into the network, and how you can use that tool in your interoperability and performance testing labs. So here is what the WaveJudge looks like. The hardware platform is a very small one rack unit high hardware device, and it is modular. So depending on the plug-in modules we use, will tell us which frequencies and which bandwidths we're going to capture. So that's the WaveJudge hardware. It's controlled with a Windows PC. So there is a WaveJudge software package that will be loaded onto the Windows PC. And essentially what the WaveJudge does, it is a RF sniffer. Okay, so that is the kind of the high-level overview or the high-level tagline of, what does a WaveJudge do? It captures an RF signal for both 4G and 5G and give you a lot of analysis, which I will talk about towards after the PowerPoint, okay? So basic overview, WaveJudge hardware captures the RF signal, 4G, 5G, and the software residing on the laptop will do the analysis. There is also a use case that some of our users already have baseband IQ. So if you are developing the baseband modules of your equipment, or you have baseband information, it actually is not necessary to use the WaveJudge hardware. You can take those baseband IQ files and import them directly into the WaveJudge software for analysis. So there's kind of two use cases here. One is WaveJudge captures the RF, and the software provides the analysis. Number two, you're using the WaveJudge software package only because you don't maybe have an RF signal. You have the baseband IQ, and we're going to use the WaveJudge software to analyze that IQ for both 4G and 5G. Okay, hope that's clear. WaveJudge is very flexible software-defined radio. You can see that you can actually cascade 2 or 3 or 4 or more chassis together to build a larger system, supporting both 4G and 5G, and it will support everything in the 3GPP specs all the way through Release 16 today, and Release 17 has been developed, but it's not been released yet. So when 3GPP Release 17, when the standards bodies release that, we will have a solution for that as well. So the point, though, here is that, we support everything in the 4G, 5G space, all the 4G releases and the 5G standalone, non-standalone, sub-6 millimeter wave, et cetera, et cetera. And here is essentially what the WaveJudge actually does. So in a 4G or 5G network, I show you that we have some base stations on the left, and base station could be an E node B for 4G, a G node B for 5G, a small cell, or even O-RAN. We support the O-RAN technology as well. So any one of those base station hardware devices will be transmitting a downlink signal towards the UE, and the WaveJudge hardware will capture that RF signal. And then the same thing happens on the uplink. On the uplink, the UE will transmit an uplink signal towards the base station, and the WaveJudge will capture that uplink. And this can be done in a cabled, conducted lab environment. Okay, so if you have this equipment set up in the lab, the WaveJudge will use a splitter to capture that RF signal. So, for example, on the downlink, typically what we see in the lab in a conducted environment is a cable which is connected between the base station and the UE. And what you'll do is use a 1x2 splitter in order to send a small part of that RF signal to the WaveJudge. So, for example, on the downlink signal, you will have one input and 2 outputs on the splitter. So one input here and one output going to the UE and another output going towards the WaveJudge. So it's important to see here that the the RF signal does not actually pass through the WaveJudge. Okay? The WaveJudge is a passive monitoring device. The path of the RF signal is just through the splitter and towards the UE, so the RF signal is not changed at all. Okay, and the same thing happens on the uplink side. You'll see here that the WaveJudge can be used with real UEs, and it is a multi-UE device. So you can have one UE or hundreds of UEs. It can also be used with a UE simulator. Keysight offers a very nice UE simulator, and if you're using that UE simulator with your base station, the WaveJudge will capture all of the RF signal for that for all of those UEs that are being simulated. Okay, so the point here is, again, in a lab cabled conducted environment, whether you're using O-RAN, E node B, G node B, small cells, all of the downlink will be captured by the WaveJudge, and all of the uplink, whether it's a single UE, multiple UEs, or a UE simulator, all of that information will be captured by the WaveJudge. Okay. We also support over-the-air captures, which I've shown here on this picture. For example, you can simply connect a downlink antenna to the WaveJudge. You can connect an uplink antenna to the WaveJudge on this module. And now the WaveJudge will capture the RF signals for whatever RF network happens to be in the vicinity of this WaveJudge. Okay? So whether it's a cabled conducted environment in the lab or over the air, maybe in an anechoic chamber or out in the field, we capture the RF signal for all the base stations, multiple UEs, and the RF signal is converted to baseband IQ. That's essentially what the WaveJudge hardware does. Okay, so WaveJudge hardware, it will collect all the RF for the downlink, all of the RF for the uplink, immediately convert it to baseband IQ, and the baseband IQ is sent to the PC for processing. Okay, so the PC is the part of the WaveJudge system that will actually do the analysis. Okay, we can see that here. Here, you can see we have two different types of analysis capabilities. The first analysis capability is layer 1 RF, like phi layer analysis, and it's similar to a VSA, but it actually gives you an awful lot more than a VSA. You see here I show, we have constellation diagrams, power, spectral power. So, similar type of layer 1 phi analysis as a VSA, but we do more than a VSA. There are some things we do here which a VSA won't do, and I'll show you that very shortly. Okay, so that's the first type of analysis the WaveJudge will give you. The second type of analysis, which is different than the first one, it's very distinct and unique, is protocol analysis. It will give you layer 1 through 4 protocol analysis for both the user plane and the control plane. So here in the middle of my window, you can see the protocol decoding for all those protocol layers, and again, I'll talk about that very shortly. So that is a very high level, what does the WaveJudge do, and what kind of versatility does it have, in order to test the base stations. We operate with any type of base station, we operate with any type of UE, and we give an awful lot of analysis for that. Okay. Also, I'd like to highlight a very hot topic today, which is DSS testing. Okay. WaveJudge also supports DSS testing, which is it's not a very difficult thing for us to do, because remember, we capture both 4G and 5G. So if you have a single base station on the left, I have two of them depicted here, but essentially for DSS, we would have a single base station, and it would support both 4G and 5G, and a part of the spectrum would be 4G, and a part of the spectrum would be 5G for DSS transmission, right? Dynamic spectrum sharing. So for dynamic spectrum sharing, the network will be partially 4G, partially 5G, and the exact same operation of the WaveJudge applies here. It's because we support both 4G and 5G, we capture both sides of the DSS transmission. We decode everything for the 4G and the 5G side, and all of the analysis on the phi layer, all of the analysis on the protocol layer is available for both the 4G portion of the DSS and the 5G portion of the DSS. Okay, and one of the big types of one of the very common analysis tests that we do there is for PRB blanking, right? What I see a lot of our users doing today is capturing a DSS transmission and looking at these resource blocks and resource elements to see whether some of them have been reserved for 4G and some of them have been reserved for 5G, and whether those are correct or they're, some of them are missing or overlapped, et cetera, et cetera. Okay, so WaveJudge is a very good tool for DSS testing, and as an example, PRB blanking test. Okay, WaveJudge supports, again, everything in the 3GPP spec. So FDD and TDD, we do both. TDD is very common now in the 5G space. You know, TDD has become much more important in the 5G world, so of course we support both. All of the channel bandwidths are supported for both 4G and 5G, so we support all of the lower bandwidths for 4G, 10 megahertz, 20 megahertz, et cetera, but we also support all of the higher bandwidths for 5G. So 800 megahertz, 400, 200, 100, all of those bandwidths are supported, no problem, on the same hardware device. Same holds for all the frequency bands. Sub-6 millimeter wave, we support both. All of the MIMO schemes, 2x2, 4x4, et cetera, multiple carriers. So today we support 8 carriers. The 3GPP spec calls 8 carriers. So yes, we can support 8 times 100, no problem. And then all of the 3GPP releases, standalone, non-standalone, all the numerologies, et cetera, et cetera. So essentially what I'm saying is there's nothing in the 4G, 5G space that the WaveJudge can't capture, decode, display, give analysis on, and help do for testing. Okay. All right. Here's a quick shot of one of the very common use case. If you're doing an test, maybe your base station needs to interoperate with multiple different vendors' UEs. So quite often, you know, we see a lab where you have an interoperability with maybe a Qualcomm chipset UE, and then you have another test where you have a test with your equipment and the Apple UE, for example. So in that kind of a use case, we display all of the UE attach, all of the upper layer protocols for both of those vendors, or for all of the vendors, whether it be any one of those, or MediaTek, or any one of the chipset vendors. The WaveJudge operates with all of those. And here you can see whether it's, you know, Apple, Qualcomm, or any of the others. We will show you the complete registration process for all of those. So this tool is used very heavily in interoperability labs where you are trying to, you know, interoperate with all the various UE vendors, okay, as well as compliance. You see here the protocol stack. You know, you can look at the various technologies and how one layer affects the other layer. So how is the protocol message related, for example, to the PHY? So because we can show you both the PHY layer and the protocol layer, we can do a lot of testing, and we have a lot of capability for specification compliance on how each one of these protocol layers interacts and affects the other. Okay, so we can see that here, and I'll show you a little bit more about that here as I switch over to the WaveJudge GUI. Okay, so now that we have the PowerPoint out of the way, what I'm showing you now is the actual real WaveJudge GUI, and I have a log file opened up, so you can see this is a real live capture. In the middle part of the WaveJudge GUI is the protocol decoding engine, and the right side is a layer 1 PHY layer analysis that I mentioned earlier. So first, let me discuss a bit about the protocol decoder. You'll notice, first of all, that it is possible to control in the settings which protocol layer is displayed and which protocol layer is hidden. Okay, so right now I'm only showing the upper layer protocols, for example, layer 3 protocols, which is the RRC, NAS, and the RATCH. So when I would show that, it shows me a very nice UE attach because we show both the uplink and the downlink on one window. So everything is displayed on one nice window, and we can see the uplink message coming from the UE, whether this is a real UE or the Keysight UE simulator. We can see the UE is trying to join the network, and then the base station is sending the random access response, requests, setups. So you can see very nice the upper layer protocols and how the UE is joining the network. We will display and decode all of the NAS messages. Now security is being turned on, ciphering is coming in. We have a reconfiguration and a reconfiguration complete. So again, if you're interested to look at just those upper layer protocols, interoperability between your base station and all the various vendor UEs, we can show you that in a very nice window, and we will hide all of the other protocol layers. However, if you're interested to look at layer 1 transport blocks, I will turn on the transport block capability, and now we show all of the physical channels. We can see PDSCH, PUSCH, the control channels, PDCCH, PUCs, all of the physical channels are displayed in addition to the upper layer protocols. We can also show DCIs, MIB, SIB, RLC, PDCP, all the protocol layers are available, and the WaveJudge will decode each one of those messages if you expose them. Okay, so as I turn each one on, you can see the window now is becoming flooded with a lot of different messages. And For each message, the WaveJudge will give you a lot of KPIs. Okay, we provide a lot of key performance indicators for each one of these messages. For example, each message will show you which UE is sending the message or which UE will receive the message, because we give you the RNTI and we also can show you the IMSI. Power for each message, signer, EVM, MCS values, et cetera, MIMO type. There's an awful lot of information that we display for each one of those messages. In addition to that, we will give the protocol decoding by double-clicking. So when I double-click on the DCI format 1 message, you can see the pop-up window, and each piece and each protocol inside of that message will be decoded, and we can see all the values, for example, of this DCI format 1. Right? We can see the resource allocation, 4164, MCS values, park process numbers, new data indicator for NDIs for retransmissions, et cetera, And that's true for each and every protocol, right? Here's your SIB1, which is a very important message. I can open up and expand that whole message, and you can see all of the protocol has been decoded for that message in plain English. And we show you the actual parameters for some of those fields. And we offer at the bottom the hex and the binary bits and bytes if you really want to kind of get down and dirty into some of those details. Okay, so full-blown protocol analyzer for all those protocol layers, and total control over which protocol layers are hidden and which are exposed. Another interesting thing and very powerful part of this protocol decoder is the error check column. Okay, so what the WaveJudge will show you in this window is more than what we've captured. And what that means is we also show you what should be sent over the air, and we will display what should be sent over the air even if it's not sent. Let me give you an example. Whenever a DCI format 0 is sent on the downlink, the WaveJudge error check, the error check software recognizes that this DCI message is scheduling an uplink transmission, which is 4 milliseconds later. So 4 milliseconds later, there should be an uplink message sent from this DCI. So you see here it's 3353, 3357. There's a PUSEH. So that is what the WaveJudge is expecting. If the UE sends the PUSEH and it's sent on the correct time slot and it's sent in the correct resource block, the WaveJudge will tell you that, okay, that PUSEH that the UE sent is okay. If the UE does not send the PUSEH at all, there will be a red error message here, and it's very easy for the user to recognize. The user doesn't need to be a protocol expert. It's easy for the user to recognize that, hey, there should have been a PUSEH here, and there's an error message here. The WaveJudge is telling me that something's wrong with that PUSEH, whether it didn't exist at all, the WaveJudge didn't capture it whatsoever, or the WaveJudge did capture something, but maybe it wasn't using the correct parameters. Maybe it's in the wrong, as I mentioned earlier, slot or resource element, resource blocks. So if the UE is not following the instructions of the DCI format 0 in any way, we will display that uplink message, but we will highlight that with an error. Okay. The same thing holds on the downlink. So when whenever you are doing interoperability or debug of your base station, the same thing holds. If the base station is sending a PDSEH, we will recognize whether that should be there or not. And if the base station is sending the PDSEH with all the correct parameters, we say okay. But again, you don't need to be a protocol expert in order to determine something is wrong. The base station is sending a downlink with some kind of problem because the WaveJudge shows me this red error message, and there will be a problem on your PDSEH downlink transmission. So very powerful tool in that it shows everything that we've captured, but we also populate protocols and different data in this window, which should be sent over the air, but maybe is or isn't or is in the wrong slot. And that's one of the differences of the WaveJudge from something like a UE log, right? Some of this information, yes, is in the UE log, but because the WaveJudge sees both the downlink and the uplink as opposed to the UE only sees one end of the transmission. So what the WaveJudge is able to do is, because we see both the DCI format 0s and the PUSEHs, we're able to do some of this interoperability test or tell you what's happening over the air, whereas in the UE log, maybe the DCI format 0 message was never received by the UE. So, if the base station sends the DCI format 0, the UE never receives it for some reason. You won't see that in the UE log. However, the WaveJudge will show you that the DCI format 0 was sent out over the air, and maybe the UE is not processing that correctly. So we stop all the finger pointing, right? Again, because the WaveJudge is in the middle of the network, we see both sides, uplink and downlink, and we're able to do a lot of things that one end of the UE log will not be able to give you that type of information that the WaveJudge gives you. Okay, and then again, we decode every single part of every single message we've captured. So I hope that's clear. Let me move now and talk a little bit about the physical layer, the layer 1 type analysis on the right-hand side of the window. However, before I do that, let me highlight something, that these two windows are connected together, and this is another very powerful part of the WaveJudge capability. What it means is the protocol list is actually connected to and correlated to the physical layer, layer 1 analysis on the right side. What I mean by that is we can show you analysis on the right side of the window that's related to one particular message. So if you choose or click on one particular message, we will show you the characteristics of that one message on the right-hand side. So for example, the time domain power chart, you see there's a red line here. What that red line is telling me is the location of the message here, PUSCH, is here. Let me show you how that works. If I click another PUSCH, I can scroll up in my protocol list, and when I find another PUSCH, when I click on it, you'll see that that red line on the right-hand side will actually move to the new location of the PUSCH that I've clicked on. So here, I just found another PUSCH. When I click it, we can see that the red line has moved. And what that allows me to do is, if I would like to investigate the characteristics of this PUSCH, I can use my toolbar at the top of the window to zoom in on that particular location. So it's really easy to find any protocol, any message, any physical channel. Easy to find that on the time domain power chart. The time domain power chart is time on the x-axis and received power on the y-axis. So what it's showing me is this PUSCH is this group of power bursts in the uplink. So the UE sent these bursts of power in the uplink. And the WaveJudge can also measure this power. We also have a measurement tool here in the toolbar. And what it tells me is there's a noise floor of minus 78 dB on the uplink, and then all of a sudden the UE transmitted a burst of energy at about minus 27 dB, and then noise floor, burst of energy. So this is the PUSCH that I've clicked on here. Okay, so that's pretty cool. That essentially what the WaveJudge does is we will find any one of the messages in this list on the time domain power chart. Okay, let me tell you how that could be valuable. In the 5G world, it's much more complex than the 4G world was. What that means is a lot of the 5G complexity, some of the 5G complexity lies in the fact that we've moved to TDD. In the TDD space, the downlink and the uplink share the same frequency, so they're sharing the same frequency band, but when the downlink is transmitting, the uplink must stop, and when the uplink is transmitting, the downlink must stop. So they're kind of sharing, frequency, and they've got to start and stop. They've got a coordinated start-stop on each downlink uplink so that they don't step on each other, they don't interfere with each other. And the WaveJudge can show you that very easily, very easily. And we have a lot of our base station testers today doing there's a lot of activity around this, downlink uplink timing offset issue. So let me show you how we would use that. What I typically do is I look for an uplink message. Maybe we look at the RATCH preamble. And remember, because we have the time domain power, we can look at the timing offset on this chart. And it's very easy to do because when I click on it, the WaveJudge shows you the location of that uplink message. So what I want to do is zoom in and look at this uplink message and find exactly what the rising edge may look like. So what I'm going to do is I'm going to zoom in to a lower level or a more detailed level on that uplink burst of power. And I'm going to continue to zoom in until it fills my screen. And what the chart is telling me is the green line is where the uplink transmission should start. So as an example, the left side would be the downlink transmission. The downlink should stop on this green line. This is for a TDD transmission. And the uplink should be transmitting on this time slot, or this period of time. And then somewhere over to the right, the uplink should stop and the downlink should start. Okay, this is a very common thing in the TDD world, where the uplink timing will change, especially whenever the UE is moving. So whenever we have mobility, the UE is moving further away from the base station or closer to the base station. Of course, the time at which the uplink transmits needs to be changed. So here we're going to be testing, the timing advance of the base station. So the base station sends a timing advance command. The UE has to use that information in order to adjust when does it transmit its uplink. Does it transmit a little bit earlier, or does it transmit a little bit later? And again, what I'm showing you on the WaveJudge is I'm looking at the actual uplink transmission. It should start here. This is the beginning of that RATCH preamble, but the actual start is way out here. Okay, so what the WaveJudge can show you pretty easily is the UE is not using this part of the time where it should be transmitting. It's transmitting too late. And we can even measure that. If you want to see a measurement of how late it is, I can use my red marker and place it here, and you can see that that is about 99 samples too late. Okay, so instead of the UE starting its transmission where it should, it's too late, and it's about, say, 9,900 samples too late. Okay, one way the WaveJudge protocol window works in conjunction with the layer 1, the phi layer window, to do some very nice analysis. One example being the uplink timing offset that I've just showed. Okay, I'm going to show one more of these charts. Oh, by the way, before I do that, let me mention that on the right-hand side, we have a lot more than 4 analysis windows. I show constellation, time domain, power, spectral, but if you right-click, you'll notice that we have an awful lot more than 4. So today I will not be able to show you all of these, but we have a lot of different charts and graphs that may be helpful in your testing, including baseband IQ and beamforming. In the 5G world, we can do some beamforming charts and graphs. We can show you the phase and the power. So you can see for each one of these categories, there is a list of available analysis on the layer 1 physical channel that I won't be able to cover today, but I hope that's obvious. The other thing we do is we show these charts for both the downlink and the uplink. So I've already shown you the uplink time domain power, but it's very easy to change that to the downlink side. Okay, so every one of these charts and graphs can display the information for downlink or the uplink. So depending on where you're having the trouble, depending on which one of these messages you're clicked on, will depend on which direction of this chart we're going to look at. Okay, good. So last one, and then I think I'll wrap it up, which is the 2D power chart. This is a very good one because it shows the resource block map. Okay, you can see here we have frames, subframes, and the x-axis. So the x-axis is time, and then the y-axis is all the resource elements and resource blocks. Okay, and you'll notice on the color-coded chart that you'll understand what each one of these resource elements would be. So the red dots are the reference signals. The pink and the yellow is a PSS and SSS. The green ones is a PDSCH. So right now I'm looking at the downlink. I'm looking at the downlink transmission. Okay, and I can see all of the assignments, all of the scheduling that the base station created. So the picture I'm showing you is not what the WaveJudge received. The picture I'm showing you is what the WaveJudge created. It understands where all the PDSCHs, all the transmissions, all the different assignments, where they should be based on the downlink base station information. Okay, so we use that to paint this picture. We also, which is very important, will show you whether the real RF transmission occurred on those resource elements, and that's really the power of the WaveJudge. So let me explain more. If I zoom in, for example, on this part of the spectrum, we can see that here's my PDSCH, my SSS, PBCH, reference signal. So this is all the information that the WaveJudge created based on the downlink, based on the information coming from the base station. I can turn on the subcarrier power measurement, and what that is going to do is it's going to show whether each one of those resource elements is energized or not. And we show that with white color, okay? And if it's bright white, it's high power. If it's black, there's no power. If it's gray, it's kind of middle power. So here you can see by hovering my mouse, we can display the actual power of every resource element on the PDSCH, minus 65 dB, you can also see that the reference signal is 12 dB higher power, right? The PDSCH is 65, this one is 53. So 12, 13 dB higher power. We can see that for PDCCH. All of the channels we can measure and overlay on top of the resource block map whether the energy was in the correct resource element. If it was not in the correct resource element, we may see it shifted to the left. So if shifted to the left or right, which means it's in the wrong time slot, or it may be shifted up or down, which means it's in the wrong frequency. It's in the wrong subcarrier. So for example, if we saw a grouping of white blocks up here above, and this was black, what that would tell me is the base station was supposed to transmit the PDSCH here, but it actually transmitted it on the wrong subcarriers. It would be up here. So that's just, what would happen if we saw some errors. Okay, I hope that makes sense. Now, let me show you one more thing. I'm going to move now to the uplink. Okay, remember we can show both downlink and uplink. So I'm going to switch this to the uplink. So let's look and see kind of what our uplink spectrum looks like. And remember how I mentioned that this protocol window is connected to the physical layer window. And that holds true for all of the charts and graphs, okay, including the 2D power. So what that means is you can very easily find physical channels on this chart. Remember before we showed how to find the physical channel in the time domain power chart, so we can see the power of the message across time. But now we're going to show you how do we find these messages on the 2D power resource block map. Okay, so if I click on one, what I show you is the location with a little red tick mark at the bottom. So again, if you click on any one of these messages, we're going to show you the location of that message. So it's that easy to find the resource block map for any one of these messages. So the PUSCH is the yellow block. If I click away, you can see I'm highlighting the blue block whenever I click it. So I can zoom again to a very nice low level. So this is my uplink channel now. We can see all the resource elements. Here's my PUSCH, and here's my DMRS. Okay. This is where the PUSCH should be. So this is telling me that the UE should be transmitting on this time slot, this subcarriers. The same thing with the DMRS. And remember what we did before. We also can overlay on top of that, where is the actual RF transmission of the UE? Does it overlay perfectly with the resource elements of where it should be? And we can see here that it does not. Okay. The first thing we see is all of the uplink transmission, all the blue blocks, some of those resource elements aren't even being used. So here we can find performance problems. If you're doing an interoperability test and you find that maybe one of the UE chipsets has a higher or lower performance versus the next UE chipset, this chart will tell you that pretty quickly if the problem is the fact that the UE is not using all the resource elements. Because if the UE isn't using some of these resource elements, the performance goes down. You won't get, the performance of the network will go down. And you can tell clearly from this diagram that this is not a base station problem, it's a UE problem. Because the UE is using some of the resource elements. This one is being transmitted at 89 dB. This one's not being used at all. It's minus 124 dB. You can see the DMRS is very consistent, right? The DMRS is minus 93, 94. So very consistent reference signals, and the UE location is not really doing the right thing. We also show here interference. I can also tell you that all this part of the spectrum, these subcarriers, are not scheduled, so nothing should be transmitted here. However, I can see that there's some RF power in some of these resource elements. So the UE might even be transmitting on some of these resource elements where it should not be transmitting. Okay, so I hope that's clear. How do we click on a message and find it on the chart, whether it be the 2D power or the time domain power or the constellation diagram, or all the charts operate the same. And then once we find that particular message or physical channel, how do we zoom in and look at various things on each one of these charts to help us debug interoperability, performance, DSS testing? It all operates in a similar kind of a fashion. So thank you very much for attending. If you have any questions, please send a message to Sanjole at keysight.com. Somebody will get back to you with answers. Set up a demo. If you're interested to see a demo, we can do that as well. And thank you very much for attending.